So, identifying and representing functions. We are still talking about x and y, and if you remember, a lot of times we're given a value for x. We'll plug in x in. We have plugged in points before. So x, the x values of a function are the input. Those are the values that you're going to be plugging in, so input, into a function, and then it's going to tell you something. The y value is what's going to pop out. Okay, when you plug in an x, it's going to give you a y. So the y is called our output. So you're going to put in an x, and it's going to pop out a y value. So how do we define function? Well, a function is basically something that has rules. So we have 3 rules here. First, x values can never repeat. So the first rule is if you have an x value, that is going to be the only time you'll see it. You can't put an x value in and see multiple answers. There's only going to be one x to one y. So for each input, you are only going to get one output. That means if you put in a value for x, it's going to pop out just one y. And that is actually the next rule. Just reiterating, for each x, there's only one y. They go together. They're a pair. All right? So switching the page, while you are saying the next half of this page is determining whether each graph represents a function. So let's follow those rules. We know that we can only have one x with one y. All right, we can't have 2 of the same x value. So in this first graph, we notice this point here has an x of -1, -2, -3, -4, -5, -6, -7. That is the x value for that green point. If I look at this next point, it's at an x of -4, but so is this one. Those 2 points are both down at -4 on your x. Right there. That represents -4. And we just talked about how you can't have that. So this brings in a test. If you see this nice bubble or fancy schmancy bubble at the bottom, it says the vertical line test. It says if it crosses 1 time, that's a function. If it crosses 2 or more times, it's not a function. And I'm going to show you what that means. You can actually draw a vertical line, which means vertical, let's review. Vertical is your up and down line. Okay, vertical means you're going up and down. That means we could draw an up and down line, and if it only hits your graph at 1 point. So here was your point. By drawing a vertical line there was only 1 point, okay? But if we were to draw a vertical line on those next points, oh, there's a point, and there's a point. So we have a point here, a point there. So on that vertical line, we have 2 points that would hit it. And you can't have that in a function. If you draw a vertical line, your function should only hit your line once, as we saw with the blue line. All right, so this is an easy test. I'm going to do the test on the next 2 graphs, and we'll see if those 2 graphs are functions. So we're going to draw a vertical line. All right, I'm only hitting 1 point on that line. So that point was down here. I am hitting 1 and no other points, just 1 point there. Let's see. I hit 1 point, and that's only 1 point. So we are good so far. So far, we've only hit 1 point on each vertical line, which is what we want. Okay, so far, we're only finding that each vertical line I draw is passing the test. There's only 1 point that is on the line. So if I keep going, I hit 1 point and none other, so that works too. I hit 1 point and no other points, so that works too. So actually, because that first graph, we hit those 2 points with 1 vertical line, so we know that that first one, that whole graph, is not a function. Whereas in that second graph, we could draw vertical lines all the way across our graph, and we only hit 1 point at a time, which is exactly what we want. So this is a function. So that graph is a function. So look at that third graph, and sometimes you can actually visualize, and you can tell that if you were to draw a vertical line, you can kind of find a spot where you think that it'll hit 2 points and show that it's not a function. So I can look at this graph right now, and I can tell that here's 1 point, 2 points. It hit 2 points on my vertical line. So already I can look at that graph, see a vertical line on there where 2 points lay on it, and know that it is not a function. All right. So let's recap. At the bottom, the vertical line test. If we draw a vertical line and our graph hits it 1 time, like there's 1 dot, then it is a function. But as soon as you have something like the first graph here, as soon as you have something like this, or as soon as you have something like this, where it hits it twice, 1, 2 times, 1, 2 times, now if it crosses 2 or more times, that is not a function. So the whole point of this unit is being able to look at a graph, or what we're about to get into are tables, and tell whether it's a function or not. That is the whole point. All right, so flip your page, and we are going to move on to mapping. And this is a lot easier than it looks. The whole ordeal with this one is looking at your x, all right, looking at your x and seeing, do you have more than one x? All right, so if you look here, each line says, okay, if I have 1 as my x, the line tells me the output is 2. All right? And there's only 1 to 1. You only see 1x goes out. Now 3, if we put that input in, we get an output of 4. 5, we get an output of 0. And it keeps going. All right? So for each input, our rule was you can only have 1 output. So each input only goes to 1 output. Each input only goes to 1 output. So this first one, I can say yes, because my x, my input, doesn't repeat. Again, we can only have 1. You can't put 1 in and get 2, and then have a second line out to another number. That can't be possible. All right? It can't be greedy and have 2 outputs. It can only have 1. So I'm going to say yes to that first one. Yes, it is a function. Because x does not repeat. Okay, so you can't have x going out twice. You can only have x going out once, all right? So in that next one, you automatically notice this 2, when it goes in and its output is 0, but then it repeats. You go back to 2 and you get 8. So I'm going to go ahead and circle that. This one, and then 4 only has one output, but 5 also, right? 5 also goes out and then goes out again. So because they repeat, this is not a function. So I'm going to write no, because x repeats. So I can say no because x repeats. The next one, if you notice, do the test again. 2 goes out once. 5 only goes out once. 6 only goes out once. 9 goes out once. And 11 goes out once. The difference here is that instead of being greedy and going out twice, they're all sharing, right? They're all sharing an output. And sharing is caring. We enjoy that. That is fine. As long as no one's being greedy and going out twice, then this works. It's a function. So remember, they can share someone an output. They can share an output and all share 6, but 2 can't be greedy and have 6 and then also have another output. This is still a function just because each x only goes out once. All right? So yes, because x does not repeat. So the whole theme here is x can only show up once. We cannot have multiple x's. So here, the 2, our x2, showed up twice. 5 had 2. You can only have one of each. All right. So we are actually repeating the same thinking over and over again, okay? Nothing's changing. From this one, we see that we have all these x values. So I'll go ahead and highlight those. We have all of these x values. And we have all of these y values. Now remember our rule, x cannot repeat. X cannot repeat. So let's look at this first one. And we see we have a 2, a 6, a 7, and a 9. As long as in that row of x's there is not a repeating 2 or a repeating 6, then we're fine. That's a function. Just look at each x category and see if a number repeats. So I'm going to go ahead and write, yes, this works, because x does not repeat. So we're looking at our x categories. Here's the x category, here's the x category. In this second category, we see there's a 3, 4, 4, 5. And we have a repeating x, a 4, then a 4 again. 2 4s. We can't have that. So go ahead and circle those and say this is not a function because x repeats. So we're just looking for that pattern. Does x repeat or does it not? If it does, then you don't have a function. You have something that isn't working, not a function. In this one, we have 0, 1, 2, 3, and none of those are repeating. They're all different numbers. So I can say that, yes, that's a function because x does not repeat. All right, in the last scenario that you are going to have to know how to look at, you are given 3 points. So an X and a Y, X and a Y, X and a Y. Let's go ahead and label those. You have a point X, Y, X comma Y, X comma Y. And what you need to do is look at the X in each point, and if you see an X that repeats, so here we have 5, 8, and 5, 9. The X repeated. We have a 5 as this X and a 5 as this X. So we already know, no, that's not a function because I have a repeating X. So go ahead and circle those. Not a function because X repeats. All right, now we see this is an X of 1. This is an X of -1. This is an X of -3. These are all different numbers. Don't get confused because these Y's repeat, and as we remember, at this point, this Y was the only Y and it was being shared. So here, 4 is just being shared by 2 different X's. And as long as there are different X's, it still counts as a function. So yes, it's a function because X does not repeat. So that is a function because the X's don't repeat. Make sure that in a point, you know it goes X, Y, X, Y, 1, 4, -1, 4. All right, in this last one, we have an X of 3, an X of 5, an X of 3 again. So that 3 is repeating. I found a repeating X. That means that is not a function. So I'm going to write no, because X repeats. And that is all of your notes, okay? That is it. If you can look at any scenario and tell me if X repeats, then you can tell me whether it's a function or not. So if we recap, we said, okay, here's an X value of -4, and then another point with an X value of -4, just different Y's. But here, we had a vertical lines showing all the X values, and each one only had one dot. So remember that vertical line test. If you only have 1 point, remember the X can't be greedy and have more than 1 point, okay? As long as you only have 1 point on the entire graph, it's a function. As soon as it gets greedy and has 2 to 1 X value, 2 dots, that's not a function. And then here, each X can only go out once. It can't be greedy and take 2 Y's. It can only have 1. All right, so here the lines just tell you whether an X is being greedy or whether they're sharing. So look at your X values and make sure that they only happen once. Here, make sure no X's are coming back for more. Like here, the 4 got an 11, and then the 4 came back and got 15 also. And that's being greedy, that's not a function. You can only have 1 X. All right, so go ahead and begin your homework. That is the next step.